In this video tutorial, we'll become familiar with the basic usage of Wireshark. Wireshark is a protocol analyzer, and it will help us dissect the network communication between different systems. So what we're going to have is working with a saved packet capture file. We're going to double click and going to have it opened up. For this tutorial, we'll be using the Kali virtual machine in VirtualBox. So once we pulled up the file, and that's the same file that we saved in a previous tutorial. In this tutorial, we transferred a plain text file using netcat from our Kali attacker to our metasploitable target and vice versa. And then one of the times what we've done is we actually went and used SSL via secure copy to actually transfer the file, and we observed the difference. We saved the packet capture, and this is what actually we're working with. To get things started, what we're doing is we're going to change some properties here. So by default, we have the file menu here with different options. And if you want to start capturing, we can click on Capture Options. And then we have different interfaces. Those are the network interfaces that are available. And we can choose to capture traffic on. All we got to do is specify them and click Start. The Berkeley packet filters are filters that allow us to capture only specific traffic. So if you're looking for example, only DNS traffic, we can specify this capture filter, and we're only going to be capturing traffic related to the filter we specified. For the output, there are different options to save the actual output to a specific format, next generation or regular PCAP. Regular PCAP is the more standard. Next generation provides some additional verbosity level. And then it gives us the location of the file we want to save. So there's some other options. We can specify how big the files are. We can specify if you want to do DNS or network address resolution and so on. And then in order to start capturing, click Start. Now because this is already saved capture, we don't need to capture anything. What we can do is start manipulating some of the default visibility of what we have in front of us. So the first things we're going to start with, we're going to go to View. We're going to change the time format. So we're going to go in, my preferred method is the year, day of year, time of day, and the specific format. So if you noticed here, the time changed, looking into the time column. Okay, so the next thing we're going to do also is we are going to change the name resolution. We're going to enable any name resolution that we can. And what this will do for us is, instead of just showing IP addresses in octet format like this one, we're going to see more descriptive addresses like PCS computer, like Google, www.google.com, as opposed to something else. If you're looking into this particular packet, we're getting wes-101-val, and this is actually the computer name. So View, the two things we did was change the time format, the name format. We can also specify coloring rules. So if you're looking for a particular pattern, we can set a particular color rule to help us to easily determine and look for that particular packet. With this in mind, what we're going to do is we're going to kind of take a look at what we have in front of us. So the file menu is on top, and each menu option presents a variety of things we can do. So we kind of reviewed what the view does. The edit, it allows us to do edits to the packet we have selected. So we can put a comment, we can set or unset time reference, and that helps us when we have a lot of packets. We can also use the find function, find next, previous, and so on if you're looking for specific content. So if you notice here, what we've seen is a display filter. So apply a display filter. So the capture filter is limiting what we're capturing. If you're not sure that we're looking for a specific protocol or artifact, it's a better practice to capture everything and then go in and use a display filter to filter out the results. So with the display filter, we're filtering what's displayed back to us out of all the captured information. So if you're looking into the edit and then find packet, we can look for a content, like val. Well, in here we're saying display filter. Well, the display filter val does not exist, so how about we look for the string val. String is just a character, and then look, we found val. So without knowing and understanding any of the Wireshark syntax, if we know a keyword, if we know a string, something we're looking for, we can use that by using the actually edit and then find packet menu or control F. Okay, let's see that perhaps I use the word west. Where does the word west appear? Well, there it is. So west, what I have is here at the bottom into the actual details, we have the word west. Something else you can notice. So notice when I hover over the west name, I see the ASCII representation, the plain text representation, and then immediately to the left we see the, what is this? 0C5745. That's the hexadecimal representation of the actual packet. And then if you look at the bottom, see how I'm moving the mouse all the way to the bottom. Let's see if I can, as soon as I move it away, it disappears. In the bottom left hand corner it says bytes, transaction ID, DNS ID. Okay, so look into parentheses, DNS.id, DNS.queryname. Those are ideas for different filters that I can use to get the result that I'm looking for. So let's say that I'm looking for west-101-val. I can use the DNS.queryname filter like this, DNS.query.name, and you notice how I start typing part of the name and there's this autocomplete. The color changes based on the syntax and if it's correct or not. Since this syntax is incomplete, I'm given an idea of what the potential query for display filter can be. Once the query is complete, if it's accurately typed in, the color changes to green, or at least what I think it's green. And then I need to specify an operator. So I need to tell the query that I'm looking for a specific pattern. In this case is west-101-val. Okay. So look into the query here. DNS query name, and voila, we came up with west-101-val. So looking through the edit menu, we can find next and so on. We already reviewed the view menu, the go menu. So go allows us to go to a specific packet. So let's say we have packet number on the left side highlighted, and this is 44. Let's go to 372. So we'll go to, and then we have this blinking cursor, 372. You see how we jumped? So we went from 44 by using the Go menu. We went to a specified packet 372 and we jumped to it. Okay. Now look, 370 and 372 have a little bracket. Now, this tells me that they're related. Sometimes you can see an arrow to the left, an arrow to the right, and this also determines the flow. So let's look into particular pattern, looking into particular packet. If we were to see these arrows, they're going to indicate a direction. Was it a packet that was received? Was it a packet that was sent? And so on. And I don't see it this time where I have those. Maybe I can do a quick scroll through. And I can't see this. But we can also get it from a different direction, from a different menu option that will show us the flow of data in a different format. So we reviewed the Go. The Go is going to allow us to jump to a particular packet. It's going to give us the packet in the conversation, and it's going to help us to kind of navigate through everything that we have. We talked about the capture option, analyze. So with analyze, it's a shortcut to different display filters. So if you noticed, once I looked into the packet details at the bottom, we were able to see different display filters or suggestions for display filters. Well, another way is to look into analyze and display filters. So here we're getting ideas of display filters. Okay. So these are the most common ones. So you're looking for an IP address, you're looking for TCP only, and so on. They give you some idea of what they look like. So apply as filter. Well, I'm looking for a specific packet, and let's say that DNS query equals val. Okay, so I'm looking for this particular packet, and in the analyze I want to apply that packet as a filter. Okay, so what I can do is apply as filter selected. So I can right click on the selected packet and apply as a filter. Okay, so I'm looking for a particular date, time, selected. Okay, time frame. Okay, and there's no other match. What else can I do with the analyze? Prepare as filter, conversation filter, enable protocols, and decode as. Now, something else interesting I can do is I can follow the UDP stream. This is one of the very common options. When you right click on a packet, at the bottom here you're going to see the packet details. The follow stream is going to allow you to actually see the data in more human readable format. So I right click and I'm seeing West 101 val, as opposed to the display in the packet details here at the bottom. Okay, so what I had to do was go in and either I can go to analyze, follow, and then select the available stream. If it's only UDP traffic, you're going to see UDP stream. If it's SSL, SSL stream. If it's HTTP connection, you're going to see HTTP stream, and so on. Then I had to select UDP stream. Okay. The other option is to right click on the packet itself and then go follow and select UDP stream. So there's more than one way to do something in Wireshark typically. And the last option is the expert information. The expert information kind of gives me high-level conversation overview from the beginning of the conversation to its end. So this, in a high level, it gives me information of what happened in the communication. So mSearch, typically can be related to AD communication. We see that connection was established with the SYN flag to port 99999. We see that the connection was SYN acknowledged, so the far end acknowledged it, and you see that essentially was the connection was tore down. We see that there was not a connection on port 48. We see there was a connection on port 22, and you see that all these connections were actually established at one point. So this is kind of a big picture overview. If you're looking into, then you can look in particular packets later. From here, what we can do is we can go in and search. We can search for a particular string. Okay, that's maybe not a good example, but let's say in the plain text. And let's see, West. So you can actually search through those to find any matching information. And let's see. We can go and colorize so we can see where this is at. We can actually find that packet if we click find, and we can do a different manipulation. The beauty of the expert info is it shows us the big picture conversation from beginning to end. There's another way to invoke the expert info, and that's in the bottom left hand side. There's a little circle. If you hover over it, you see that it says chat is the highest expert information level. Okay, so you go and left click on it and it shows you that conversation. Statistics. So from analyze, we're going to go into statistics. So you can see the capture file properties. The protocol hierarchy is one of my most frequently visited places. Protocol hierarchy tells me in a big picture what data was transferred. Okay, so you got to be very careful because at the moment I've selected only a couple packets. So notice here I have 2 packets, and the information for the statistics is going to be limited. So I'm going to go ahead and clear the filter, and that was by actually going in and clicking red X. So once I cleared up the specified display filter, I can go back into statistics and then go into the protocol hierarchy. So now the result looks a little bit different. What we're seeing here is a high level of the protocol communication. So the protocols are different. Think of it as rules to communicate. So we're using different syntax, different form of rules to exchange information. So we see that we have SMB protocol exchange. We see that we have some data. In the transfer control protocol, we have data, and we also have SSH for secure shell. So if you recall from the previous tutorial, we actually transferred files. So there'll be data. Let's say that we're interested in seeing the SSH protocol. Where in this protocol hierarchy can we see only the SSH protocol information? Well, select the protocol, right click, apply as filter, and go selected. So if you're looking in here, we should be able to see only the SSH protocol. So this is all the communication associated with this SSH protocol. Now, being an SSH, unless you have a man-in-the-middle type of proxy, or you're setting up an environment variable through a browser to be able to intercept the traffic and decrypt it, a lot of this information is not going to be end-user readable, as you can notice here. So with this, I went into statistics and the protocol hierarchy. I wanted to, it looks like again I need to clear the filter and go back to my statistics, protocol hierarchy, and I wanted to pay special attention to data. Data is plain text, anything human readable. So if I was to go and select and apply this as filter, I'm going to see any human readable data. So in here, you can see that, starting with the first packet, what we can see in the packet detail is this is a test. Next, we read this is a test. Maybe click in the middle, we see the pwd command. And again, how can we find an easier way to read this? Right click, follow, TCP stream, and voila, we can actually see the entire conversation. So anything with red is going to be what we send. Anything in the blue underneath is going to be what was received from the target. And if you recall, we executed print working directory, and the response was the working directory is home msf admin. We executed show me the contents of the etc_passwd file, which contains usernames, which is different than the indicative passwd. It does not contain password hashes. Those hashes are located in a different file called the shadow file, at least for most Linux systems. And then we see the result of the actual command. So that's only by using the data. Now, with what other statistics can we see? We're looking into conversations. So in the conversations, we start with Ethernet protocol, and this is anything initiated by our interface card. The IPv4 is the actual addresses we conversed with. So we know in our line of communication that 1 is our router, 56.100 is, this is actually the multicast address. This is the actual router for our private network. And then we know that the actual addresses are 101 and 103. So those are the only two addresses that conversed. Okay, so if you look into the configuration for our Kali, we can determine what is the source and the destination. So at this time, the IP address for my Kali is set as 101. Okay, so as 101. So if I go into statistics and I look into the conversations, I know that any information coming from 101 is from my Kali VM, and 103 is the destination. Now, how can I tell in here which one is the source, which one is the destination? I'm going to use the filter IP.address 168.56.101. Okay, so this is all the communication from 101 and destination 103. Okay. So it's going to be difficult to determine which one is the source, which one is the target. We have to determine kind of the pattern, what activity took place, what the communication looks like. You probably have to look into, if you're given a packet you didn't know, what is the sequence, where was the connection initiated, from which system to which system. So if you look into the chat here, we see, what is the source, what is the destination. So if we don't look into the actual display here, we're looking into the packet contents. Okay, so look into the packet contents. We're seeing that in the Internet Protocol, we have source was 103, destination 101. So we have to read the packet detail to determine what was the source of the packet and what was the destination. Now in a communication, we're going to have the attacker being the source of a packet and then the target being the destination. But also when we receive a response from the target, we're going to see the target as the source of the response and then the Kali VM as the destination. So what we have to determine is, when we're talking about the source and destination, the attacker and the target both are going to be the source or destination of traffic in the context of this particular conversation, and what happened for a particular activity, we have to identify the source and the destination. So looking into the statistics, we're into the conversation. From the conversation, if there was IPv6 traffic, we can see this, and it looks like it was mostly TCP traffic. Okay, in mostly TCP traffic, we see that address A was communicating using these random ports with address B. Okay, and those are the three most common ports that were used. Again, from here you can do apply as filter, prepare as filter, find, colorize, and so on. So if you colorize, you have options, the direction from A to B, B to A, and so on. And you can always, experiment and make it more complicated. And then this is the UDP traffic. So the statistics menu provides some valuable information. Now, endpoints. Endpoints is very similar to the conversation. Those are the different endpoints we communicated with. Okay, and you're going to notice very similar information to the conversations. From the endpoints, another thing that we can use is a flow graph. Okay, so if you look into the flow graph, a flow graph tells us the actual communication. So this is the packet flow, data flow, if you will. So we see that we had a conversation from 56.1, and then he went to 239 to 55 to 50 was msurge. It was from this port to this port, and here's the conversation. It was from the computer that I use, and it looks like to the other computer, and there was a response. We see kind of this flow of conversations and the actual history. So if you look at the bottom, I go into a particular flow, or I go into a particular transaction, and it's as soon as I mouse over it, in here, you see how it says packet 23. It says browser, local master announcement, metasploitable workstation server, PrimQ server, Xenix server, or whatever. So it tells me information of what the actual conversation is about. The actual comment is displayed here. Okay, it says who has this, who did that. Okay, and it gives me that information. If I continue scrolling through, I can see the entire interaction, entire conversation in a different representation. Now notice I need to move the horizontal bar as well as the vertical to be able to see that entire conversation. You can also output this with I think in CSV, and you're able to map it using a different tool. So you can do it as a PDF, you can do it as ASCII, you can do it as a picture, and so on. This is what I use to actually help me determine data flow if I'm not sure how a particular service is interacting with systems, clients, databases, and so on. Okay, so that was the statistics, and those are the only ones I'm gonna focus on at this time. So once we reviewed the tool menu, the different options here, we talked about the display filter. Let's talk about what you're seeing in front of us. So the first column was the number of the packet number. Next we have the time, the date time. Next we have the source address, and we have the destination. As we talked about, the source and destination, the information is going to be varied because we have two-way communication from Cali to target and from the target to Cali. We're seeing the protocol that's being displayed. We're seeing the length of the actual packet. We see information about the packet, and what we're reading here is the packet length was 74 bytes. We see that there was a particular port that was reached. The distinct port, the source port was 50,000 304, the destination was 4 nines, and we see the packet that was a SYN request. That was the beginning of a connection. Then we see the window size, the length, and some miscellaneous information. So using the length and the window size, we can actually determine what operating system we had. So let's see, if I was to apply this TCP stream, let's see what's this there. So this is a test from Val. So with this in mind, now we got to look for artifacts. And where do we get started? Well, it's kind of difficult to know what you're looking for. When I'm investigating a particular data flow, I start with some easy things. I'm looking into, data. So filter like data. Show me anything that's human readable. Well, great, anything that's useful. So if there was a plain text data transfer, I'll be able to see it. Something else that I would do is HTTP that request. So if there are any HTTP requests, okay, are there any browser requests from whatever machine to a web server? Typically when there's malware, there's a callback, and that's to a particular server via IP address or DNS resolution or so on, and we'll see some information here. When we're looking for a particular address, we're not sure if it's the source or destination, we can use the IP.addr filter, and this is going to show us any information for this IP address as the source or the destination. Okay, let's say that we want to make sure that this is only the destination. Okay, so let's say IP.dst. So I want to see any communication as the destination of this IP ending in 101. Then I'm going to hit enter, and notice in the destination, everything identified as destination of this address. Now, there's a difference between IP.dst and DST host. Okay, look what happens when I do DST host. DST host is actually a domain name. Okay, so I'm looking for a particular filter with the domain name in there. So the DST is just the IP address. The DST underscore host is referring to a DNS resolution. Okay. Now, what if I would like to say that the communication was IP destination was 103, our target, and the destination port was 4 nines. Okay, so TCP dot port equals 4 nines. Well, notice this. So TCP port is 4 nines. I said, I want the destination to be 103 and the port to be 4 nines. Well, how do I know if this is the destination? I'll look into the actual packet details here. We see the source is 101. We see the destination is 103. This is the Internet Protocol. That's telling us the IP addresses. Let's look into the actual transport protocol, the TCP. Look at the port. The source port is 4 nines. Okay, the source port. So the source address is 101. The source port is 4 nines. What we specified here is I want the destination to be 103, and then I want the port to be 4 nines. The port, I didn't specify if I wanted to be the source or I wanted to be the destination. So what we got is, because what we received is, they didn't specify source or destination. We did both. In order to specify that I want the TCP destination port to be 4 nines, then I need to use the TCP.dst port display filter. Now I see that I don't have any results. What if I do the opposite? I do the 101 and I see the destination port is 4 nines. Now I have results. And what happens here? I see that the destination port distinct is 4 nines. So when we're filtering for different data, it's very important to understand the syntax for the particular filter. And we're going to provide a reference link to the Wireshark filters, and they describe the definition of it, what we can do with this filter, and so on. When you're not sure, the best practice is to start with the statistics menu or the expert info and work your way through understanding the actual conversation, understanding what you're looking for, help you navigate. And then once you identify strings, you can also use the Go menu. You can use the edit menu to find a packet. Once you become more proficient and you know some of the key display filters, you can start typing them directly into the display filter field. Now, let's say that I'm looking for a particular packet that contains information. Contains is looking for a string. And the major think of it as Google search. There are several ways to do a Google search in Wireshark. We can try to use the edit and then find packet, or we can use the display filter. I'll show you how we can do this with the display filter. The three filters that we typically use is data. So data contains, okay? Data contains a string. Data contains, let's say, the string bash, okay? Data contains bash, and notice how I enclosed my keyword in quotes. That's required or not required, depending on what you're using. To be safe, I try to do it with a quote. So if you're noticing here, I have a matching pattern, and that's bash. Bash, it's a bin bash, okay? And this is in plain text data. Now, let's say that I'm not sure that there's a plain data. I want to look for the entire frame. Frame, that's at the layer 1 setup. At layer 1, we can look into anything that's captured that contains the word bash. This is more of a global search. And the other way, this is the second. So we got data, frame, and TCP. So the TCP stream contains, the transfer control protocol contains bash, okay? If you're working with HTTP requests, HTTP, that request contains so the syntax is not applicable to every single command. So we got to be cognizant of what the options are. And I'll provide a reference on how to find that. Now, with this capability, you'll be able to look for certain patterns. So we're looking for plain text data. We're looking for artifacts like a name, a username, maybe a credit card number, a particular port. Essentially, you're using Wireshark to help you put pieces of the puzzle together, draw the big picture, and then focus on particular segments. It's important to know that Wireshark is not intrusion detection. You'll be able to pivot and inspect the packet, but you will not be notified if the packet is malicious. For this purpose, and get those notifications of malicious content in our communication, is we typically use a host-based or better, a network-based intrusion detection. Typically, the network-based intrusion detection, like Snort or Suricata as the backend engine, allow us to dissect the packet content and then apply different rules to match for indicators of malicious activity. And we'll cover this in a different tutorial.